Have you ever cut across a vacant lot? We know it is shorter to walk this way than it is to walk around the corner. One way to find out how much shorter is to count your steps. But there is another, more accurate way. We'll find out about it as we learn about triangles. As you probably know, a triangle is a closed figure having 3 sides and 3 angles. We can also define a triangle this way: a figure composed of 3 points and the line segments connecting them. Triangles are not only important to us in mathematics, but are also commonly used as an important element in architecture and in engineering design. We can identify triangles by relationships among their sides. In an equilateral triangle, the 3 sides are equal. With 2 equal sides, we can form an isosceles triangle. A scalene triangle has no 2 equal sides. The perimeter of any triangle is the sum of the lengths of the sides of the triangle. Triangles are identified not only by their sides, but also by their angles. Since this triangle has one obtuse angle, that is, one angle which measures more than 90 degrees, it can also be called an obtuse triangle. A right triangle is a triangle having one right angle. An acute triangle is a triangle that has 3 acute angles. That is, the measure of each is less than 90 degrees. The total number of degrees in the 3 angles of any triangle is 180 degrees. Thus, whenever we know the size of 2 angles, we can always find the number of degrees in the 3rd one. With 2 triangles, we can demonstrate congruency. This is another important concept. By indicating the line segments this way, we can see how triangle ABC fits exactly or coincides with triangle XYZ. Line AB coincides with line XY, BC with YZ, AC with XZ. Angle A coincides with angle X, B with Y, and C with Z. We see that if 2 triangles are congruent, all 6 parts of one triangle, 3 angles and 3 sides, are equal respectively to the 6 parts of the other. The triangles are also equal in area. Congruency will help us demonstrate how we derive this formula for the area of a triangle. Area equals 1/2 the base, B, times the height, H. First, on the base of the triangle, we construct a rectangle. The rectangle and the triangle both have the same base, B, and height, H. We see that triangle AFC is congruent to ADC. We know that these 2 congruent triangles are equal in area. In like manner, triangle CBE is congruent to CDB. We know that these 2 congruent triangles are equal in area. Thus, triangle AFC and triangle CBE together are equal in area to the area of our original triangle, ACB. We know that the area of a rectangle equals the base times the height. So 1/2 the base times the height must equal the area of a triangle. If the original triangle has a base of 10 inches and a height of 5 inches, the triangle has an area of 25 square inches. One of the most important theorems about triangles was credited to the Greek mathematician Pythagoras. It became known as the Pythagorean theorem. The Pythagorean theorem applies to all right triangles. The hypotenuse is the side opposite the right angle. In the theorem, the area of the square on the hypotenuse is equal to the sum of the areas of the squares on the other two sides. In this right triangle, the sides are 3 units, 4 units, and 5 units in length. Using the Pythagorean theorem, let's see if the measure of this area plus the measure of this area is equal to the measure of the third area, the square on the hypotenuse. We proceed as follows. 3 squared is 9. 4 squared is 16. 9 plus 16 equals 25, the square on the hypotenuse. Using this theory, we can always find the third side if we know the other two. Remember the problem we saw earlier? The Pythagorean theorem will help us find out how much distance this boy is saving. We'll use as our unit of measure a section of sidewalk. The path which is made by his crossing is the hypotenuse, C, and we wish to find its length. Sides A, B, and C form a right triangle. The length of side A is 20 sections of sidewalk, and the length of side B is 15 sections of sidewalk. Using the Pythagorean theorem, we can find the length of the unknown side, C, since we know the lengths of the other two sides. Our formula for calculating any one of these distances, when the other two are known, is A squared plus B squared equals C squared. Side A measures 20 units. 20 squared is 400. Side B measures 15 units. 15 squared is 225. The sum of these two squares is 625. When we take the square root of 625, we find it is 25. 25 sections of sidewalk is the length of side C. The other two sides, 20 and 15, total 35. Subtracting 25 from 35 gives us 10. The boy has saved himself 10 sections of sidewalk. In this problem, we have a ladder 24 feet long. The distance from the bottom of the ladder to the wall is 6 feet. What then is the distance from the ground to the point where the ladder is resting against the wall? In this case, we want to find the length of side B. Using the formula A squared plus B squared equals C squared, we can make the following calculations. Side C, representing the ladder, is 24 feet long. 24 squared is 576. Side A, the distance from the bottom of the ladder to the wall, is 6 feet. 6 squared is 36. Subtracting 36 from 576 gives us 540. This is the square of side B. To find the length of the side, we take the square root of 540, which is 23 2/10. Side B, the distance from the ground to the point where the ladder is resting against the wall, is 23 2/10 feet. How to find the length of an unknown side of a right triangle is just one of the important things we have learned about triangles. We have also seen that triangles can be identified according to the measures of their sides or their angles. We learned to find the area of a triangle by using the formula area equals 1/2 the base times the height. As you continue with your study of mathematics, you'll find that the solutions to many kinds of problems depend on your knowledge of triangles.